Hello, in this video we are going to see how we can obtain the tan inverse of x. So to begin with, you multiply both sides by tan. So to obtain the following, on the left hand we will have tan y, on the right hand side we will have tan multiplied by tan inverse of x. And tan multiplied by tan inverse of x, the result will be x. Then we differentiate both signs with respect to x to obtain the following. After differentiating, on the left you shall have sec squared of y. Note that the derivative of tan is sec squared. Now because we are differentiating with respect to x, we multiply by dy over dx because this is implicit differentiation. Then we divide both signs by sec squared of y. To obtain dy over dx or y prime is equal to 1 divided by sec squared of y. Then we made use of this identity. 1 plus tan squared y is equal to sec squared y. And we made the substitution here. The tan of y is x. So we substitute here where you have tan y, we write x and we square. After doing that, we shall obtain 1 plus x squared, which is equal to sec squared y. So we come and substitute our value of sec squared y with 1 plus x squared. So y prime is equal to 1 divided by 1 plus x squared. Hence, to differentiate tan inverse of x with respect to x, the result is 1 divided by 1 plus x squared. So the recap of what we have just done here, you are going to find the derivative or you differentiate tan inverse of x. So the first thing which you have done here is to multiply both the left and the right with tan. To obtain tan y on the left is equal to tan multiplied by tan inverse of x. And on the left, we have made use of the law of indices, whereby here you have tan power 1, 1 plus 1, 1 plus negative 1 is 0, and anything to power 0 is 1. So 1 times x is x. Then from there, we have differentiated on the left tan of y implicitly with respect to x to obtain the derivative of tan is sec squared dy dx, which is equal to 1. Then we have divided both sides by sec squared of y, so that on the left we are left with y prime represent dy over dx, meaning that we are differentiating, we are finding the slope of the function with respect to x. Now we have made use of this identity of trigonometric, which says that 1 plus tan squared of y is equal to sec squared of y. And we have made the substitution here, whereby we know from what we have done above, tan of y is equal to x. So where you have tan, you substitute with x. And because now tan is squared, you square. So 1 plus x squared is equal to sec squared of y. Then we come to this equation here, where we have sec squared of y, we substitute it with 1 plus x squared as shown here. Then from there, we have concluded that the derivative of tan inverse of x is 1 over x squared. Remember, mathematician, if you have not yet subscribed to this video, kindly consider to do so. You can like and you share with the other mathematician. Also remember to click that notification bell so that you shall be notified whenever there is a release for you. And thanks so much for taking your time to study with me on how to obtain the derivative of inverse of trigonometric function. In our next presentation, we are going to see how you can obtain the derivative of cot inverse of x. Kindly, you can comment on any approach which you know on how to obtain the derivative of cot inverse of x. Also, you can check on my channel where I have done it in the subsequent video on how to obtain the derivative of cot inverse of x. Bye bye for now. Thanks so much for taking your time to study with me. See you in the next video. Bye.